Here we have the 2021 question 10b. Population of insects in a region grows at a rate that is proportional to the current population. So we're given here dp over dt, or dp dt is equal to k times p, where k is a positive constant. In the absence of any outside factors, the population will triple in 15 days. Find the value of k. We might do this two ways. The way I would teach you this at leaving cert, ae to the power of bt, or kt, is going to be the population here. So if we say that if it triples in 15 days, it's going to be, the initial population is going to be a, and t is equal to 0. A is the initial, so 3a will be 3 times that in 15 days. So we divide by a, we're going to get 3 is equal to e to the power of 15. We change it to k for this question. So 15k by the natural log of e is equal to the natural log of 3. So k is equal to, this is equal to 1 obviously, k is equal to the natural log of 3 over 15. So that gives 0.07324 0.07324089192. Not ask for anything here. The next number is 0, so I'll just leave that one out and leave it as 0.07324. Yeah, just double checking it. Now we could also do dp as we're given, dp dt is equal to k times p. So if we want to get p, we're going to have to divide by p to get dp over p is equal to dt, or k times dt, this positive constant. So we integrate the left and the right, and the time is between 0 and 15 to get the population going from p to 3p, if we do in terms of p. And if we integrate this, we're going to get the log. I use the log to the base e when I do these ones. Same as natural log of p between p and 3p is equal to k times t between 0 and 15. So we're going to get the log to the base e of 3p minus log to the base e of p is equal to 15. Putting 15 in for t, we're going to get 15k. So we get log to the base e of 3p over p is equal to 15k. So log to the base e of 3 equals 15k. So similar to above where we're using natural logs, we're going to get e to the power, we're just looking for k, we're just going to get log to the base e of 3 over 15 is equal to k. And if you're checking your calculators, that also obviously gives the same answer, 324. So that's the first part. The second part, a scientist begins to remove 10 insects from the population each day. If there are initially 120, so this a is equal to 120. In the region, the population will not survive. After how many days will the population die out? So initially 120, so we're going to have dp dt is equal to this positive constant times p minus 10. So we're going to have our integral starting at 120. I think it's the easiest way to do this. So if we simplify this to be dp over kp minus 10, we have k as a decimal. I'll leave it as k for now. That's going to be equal to dt. And if we want the time taken to get to 0, we're going to have to integrate the left hand side, which started at 120, and it's going to go to 0. So let's just bring up something here about integration and absolute value. You can see here when you integrate 1 over x, you get the absolute value of x in the integration side, so just be careful with this because it does create a minus. So if we integrate this, we're going to get 1 over k times, I'll just use natural log this time, the natural log of kp minus 10 between 120 and 0. So putting 0 in first, we're going to get 1 over k by the natural log of minus 10. So I'm just going to take 10 for the absolute value, and then it's going to be minus the natural log And if you put 120 times k minus 10, it's going to give negative. So put in 10 minus 120 by 0.07324 into your calculator. And putting the same number in here, 1 over k gives 13.65 on my calculator. Multiplying the whole thing out is giving me 28.82 for time. And that's after how many days? So we can say maybe after 28.8 days, or after 29 full days, or on the 29th day, the population will be gone.